the RS-75. So the first thing we're going to do is get a video running on the RS-75 to show you a different application, and then we're going to come back and go to more detailed things. So I hope you're having a good session to start. So the application video we're going to look today is to make like a piece I'm holding in my hand at the end, which is a sub core for engineer floors. The process there is going to show you two saws. The first one that make the groove under the underlayer grooves, and then that will cut the sheet into strips. So the full process of the video is to start from a full sheet, and the first operation is to make the groove under the panel through the ERS, and then go to the RS-75, which is a more standard product, to cut the sheet into strips. And then strip could be cut in different width based on the setup you have at that time. The idea is to cut your sheet into multiple strips that will be required for the process line. The RS-75 multiple blade rip saw comes with a 40 horsepower motor for the arbor and a separate motor for the feed rollers, which consists of 4 feed rollers on the bottom and 4 pressure rolls on the top. It also has a 60-inch width capacity for the panel. The system we are seeing today is showing also a AP feeder arm to separate panel at the entry point. It could feed panel into a rip saw, a laminating line, or even just a beam saw. There is also a version with vacuum cup for the layer separation. In this example, it could have been set directly in front of the RS-75 to feed directly into the saw if you are not having the grooving saw in front. System today is also showing the ERS saws, which is a specific saw for the engineering product line. This saw is mainly designed to make the curved groove under the core layer. It's used very similar component, the RS-75, with a removable arbor, but it's driven by chain, and also it could go up to 8 foot wide. When we sell a RS-75 rip saw, we highly recommend to have a roller in feed with alignment feature. The main feature for that conveyor is to make sure the panel is well aligned before it enters to the saw. The goal is not to align the panel in the saw. The goal is to make the panel straight up before it enters the saw, and the saw feed rollers and pressure roll will just keep the panel straight as it's going through the saw. Important feature of the RS-75 is the pressure roll on the top. So over each feeding roll, there's a pneumatic pressurized pressure roll on the top. On these images, we can see they are just under the orange rectangle that we see on that picture, and a little bit farther on the images you can see the pneumatic cylinders. So these cylinders will come up when there is no panel and come down when the panels appears in the saw. There's an option in which you can have all those rollers going on sequence as the panel progress, or you can have them all going down at the same time. Because now also all those rollers could come up very easily. This is why it's easy to adjust the thickness of the panel you're being processed by turning the wheel device with a different height adjustment there that you can set up very easily at your shop for different thickness. So you raise up the panel, you turn the wheel, and then when you're going down, all the panel now are at the same height again. Quick overlook of the HMI, that is for the AP feeding device. You can see at the top where you can see all the starting of the motors and stuff like that. You can see at the bottom where you can adjust the arm travel based on your panel length. How many panel was the request for your production order? How many panel you have fed for that order? And now it's also, you have a big count for the full day production, and also the panel thickness for the AP feeding device. The next sequence in the video, we're going to focus on the swapping of the Saw arbor for a setup change. The full sequence for swapping an arbor from the other will take about 15 to 20 minutes for a train operator. For safety reason, there's different safety device on the saw chamber to make sure the operator cannot get access to the arbor while it's operating. First of all, on each side there's a door with safety lock access where you need to request access, and there's a timer delay for opening the doors after you did request access. Plus, as we can see on that images, there's an orange disc attached to the arbor. That's a rotation detector, which is doubling up any other signal from the axis rotation. Just take note that for the video sequence, we just speed up the images so you can see the full sequence, but just at a faster speed. The 15 to 20 minute count that I gave you earlier is based on the fact that normally you will have more than one arbor set up. So technically the 15-20 minutes will be to pull out the arbor and right away slide another one prepare arbor directly into the saw. So we are back to our studios. Then we're going to cover other few details here on the saw. So first thing, we call it the RS-75 because it could run at a feed rate of 75 feet per minute. And it has a 40 horsepower, as we quickly said in the video. So now I want to bring your attention to a couple of things. When we develop a saw or work on an application for the customer, we try to avoid making a strip on the edges. That's why here I can show you an example of what we call an auger blade, which is a thick blade that will cut or grind any type of a 1-inch strip on the side. Also, we can see another view of the orange detection disc that we quickly saw in the video, except now you have the full view of it, which should stay with the shaft no matter if you're coming in and out. And also there's the panel support bar, which are removable bar that support the panel. So when you do the setup for the arbor, you slide your arbor in, you put all your spacers and blade, and then between the blade, you can slide those bars that maintain the panel at the right height while it's being processed. Next, Anthony. So as I said, it's kind of that's the view of the arbor before it will slide in for the cartridge, the support bar. So we can see each blade with spacer between. So those spacer can be as close as we made some setup with about a 1-inch spacer between. So it can be very close. Right now, the setup is about on a 3-inch spacing. And we can see how the cartridge will slide in and out from the arbor of the saw.
what we could see here is a direct feeding to the RS-75, which is back there in the picture. So here I got an AP feeding directly to it, so over the roller conveyor and then to the saw. So the next picture I'm going to show you is a closer view of the conveyor in front. Similar to the video, you can see the feeding roll that maintain the alignment after we create it. But what we do with those normally feeding conveyors is after the panel has been sent by the AP feeder, that orange bar will come and close, aligning the panel with the reference edge, and the roller are slightly inclined to maintain that reference as it's being fed to the saw. Pressure roll, that's why we look out that picture. I want to show you the pressure roll on the top. So we got, as we said, driving roll at the bottom, and on the top we have a segmented pressure roll. Reason why this is segmented is normally sometimes panel could be not as even, or there could be some little thickness differences. So by having it segmented, it will not affect the speed from one roller to the other, and there's a slight difference. And also you can see one ear, which is typically raised up in the air over the saw chamber. So next picture, as we could see, that roller will come down right over the saw arbor. So that reason is if you need to do like a beadboard panel or just a grooving application, we normally have those same roller right over the saw blade to make sure we control the depth of the groove, or some people call it the curve. So the depth of those grooves are being constant as the panel is being processed. Finally, another thing, this saw is a different model. So we have the RS-75, which is a 75 feet per minute, 40 horsepower max on the motor. We have also the model that we call RS-120, which is a higher speed rip saw, who could go up to 120 feet per minute. And if it's our application that could require its base, the base motor is at 75 horsepower, and we made some other saw with higher motor based on the requirement. Even here, we got an application that we built where even with the main saw chamber, which would have the arbor slide in and out at that point, there was a second saw chamber. So in the same saw frame, there was a second saw chamber that was added on. So it's kind of, even with our rip saw, we can go on the customized side of it if you ever need like a special application. Do we have any question, Danielle, on the saw? No, so I have no sign. There's no more question. So we're about done with our presentation at this time. Thank you for participating. I will invite you for tomorrow's session, which will be at the same time, where we're going to jump this time into the clamp carrier, RT100 type of clamp. And hope to see you tomorrow. If you have any other question, feel free to email us or contact us via the chat of the platform. We'll take the time to answer your question as we need. So at that time, see you tomorrow, and look at our YouTube channel for other videos. Thank you and have a nice day.